Okay, so today's lesson is going to try to save you some time and effort. It's going to try to make your life easier. But before you do that, of course, there's an element of thinking involved, and that means you also need to, well, you're going to have to sort of stop and think before you try your quadratic formula. Ready? To recap from last class, I gave you this exact example when we were first learning the quadratic formula. Okay, so the quadratic formula determines the roots of an equation when you set the y value to equal 0, even when the equation cannot be factored. True? I hope you agree with me. So as an example, if the function is x squared minus 8x plus 12, as long as I know that the y value is a 0, or the function is set to 0, I can use the a value of 1, b value -8, c value +12, plug it in, and I get myself the answers 6 and 2. What does that mean? It means at +6 and +2 are when the y value equals 0. Okay. Well, and of course, if we change the roots and the y value didn't happen to be 0, we can rearrange it, so on and so forth. But for now, this is it. Consider this. If the quadratic formula, okay, so I'll write it here. If quad formula gives us x-intercepts, consider these graphs on the bottom. I'll do it in red, so it's nice and in your face. If the quadratic formula is supposed to give us x-intercepts, you need to also consider two different scenarios that you might not have expected. Look at the left graph. This is a graph of x squared minus 8x plus 16. How many x-intercepts are there? Come on, not rocket science. Yep, 1. There's only one x-intercept. What is that x-intercept? When y equals 0, x happens to equal a 4. That's it. Why is it still not in? Not right. Okay. What about this one? This is on the right side. It's still a parabola, right? It's still a parabola, but are there any x-intercepts? What's the lowest point? The lowest. What is the vertex of that parabola? Is that 4? Not 0. Still too high. Cameron, with me? There are no x-intercepts. In other words, you can say when y equals 0, x does not exist. So I'm going to consider today to be sort of the final piece of the puzzle. What do you do when you are given or you're dealing with a parabola and this is actually what it looks like? What would it look like to you when you try to calculate it mathematically? Right? So again, going back to the quadratic formula, if the quadratic formula is so amazing and gives us x-intercepts, or gives us the roots rather, what would it look like when there's only one possibility? Or what would it look like when there's absolutely no possibility? Because every single time we did a quadratic formula, look at our practice quiz, it always gave us 2 answers. So if the quadratic formula is doing its job, it should also have the ability to give us 1 answer, and it should also have the ability to give us 0 answers. So let's try it. Taking the first equation, I'm going to take x squared minus 8x plus 16, plug it into the quadratic formula. what do I expect if I plug it into the quadratic formula? How many answers do I expect? If I plug these numbers in, I should only get one x-intercept. I should only get one answer, right? So again, quadratic formula is supposed to give us these. It's supposed to give us these. But for this graph, it better give us one. Otherwise, the quadratic formula is not as useful as we thought. It better give us some kind of problem. It better give us some kind of error for this one, or the quadratic formula is not as good as we thought. The whole point of quadratic formula is to be able to find the roots when you can't factor it. So let's go. I'm going to do the first graph right here, and hopefully the formula gives me one answer. And then we'll do this graph here, or this function here, and hopefully it will give us 0 answers. Turn to the next page. So before we go on, I will mention something about a discriminant after we solve, okay? So stay tuned for that. Let's plug it in. The A value, B value, and C value for this function is 1, -8, and 16. So let's plug it in. X is equal to, wish me luck. Here we go. -b, -b, plus minus b squared. Cool. You know what? Is there a way to? I'm gonna do this. I'm getting sick and tired of trying to use the mouse today. Negative b plus minus square root of b squared minus 4 times a times c all over 2a. Let's do that. Oh, whew. My goodness. So far, so good. Yep. Yeah. Real quick. So plugging in the numbers. By now, I'm hoping that at least plugging in the numbers is natural. Let's simplify. Negative. So minus a -8 is a +8. Plus minus square root of -8 squared is 64, and -4 times 1 times 16 would be -64 over 2. So plus minus. Some of you who are, I guess, faster at writing, and you're able to sort of take a step back and see what's going on here. I hope you recognize it, right? So again, as I said, this thing, we're going to expect one answer. What do you notice about the square root portion? And what do you get when you square root a 0? 0. So if I add or subtract a 0, does that change anything, Cameron? No, right? It doesn't. 8 plus or minus a 0, I'm not going to write that. That's a waste of my time. So 8 divided by 2, what's my answer? Recognize that form? It's only one answer. plus or minus, I'm going to write this down here actually, just because that was the whole point. Plus or minus a 0, right? The square root portion turns into a thing that doesn't change the value. So, therefore, 3 dots. I can't do 3 dots here. Therefore, okay, when y equals a 0, x must equal 4 only. So what do you notice about the square root portion? What happens if the square root is a 0? I only get one answer. So what do you notice about the discriminant, the area under the square root? It's that if the discriminant equals 0, there is only one root. That's the point. So the quadratic formula works even if there's one x-intercept only, or one root only. So there's my intro to a new word. Do you notice what the x, so the discriminant is a special word used, I'm going to say pretty much exclusively just in math, but it comes from the same root word for discrimination, right? Discrimination in society is sort of a negative term, but the root discriminate is sort of more categorize, right? Does that make sense? Right? To compartmentalize, to categorize, to group. In the same way, the discriminant here, the reason why we call it a discriminant is because that portion will categorize your answer as something that has 2 answers, 1 answers, or even 0 answers. So you're looking for that discriminant first. So if you were savvy, every single time you have to do the quadratic formula, you would test the discriminant first. Now I'm going to do the long way for the next question just to show you. But after we do that, maybe I'll show you the short way, or maybe an example question to see what you could do to save yourself a lot of time. All right, let's get to it. Next question. For the function, so this is the other graph. So this is the right side graph, minus 8x plus 18. Let's try it. If the quadratic formula works, this should give us no answers. So once again, a value, 1, b, 8, negative 8, c, 18. Let's see, x is going to equal negative b plus minus square root of b squared minus 4 times a times c, all over 2 times a. So there's a line here, it's a fraction. There is a plus or minus here. There's a square here. Square root there. Don't go too far. I am going to simplify. But here it is, 8 plus minus square root of 64. Negative 4 times 1 times 4 is a negative 72. So, what is the discriminant? So let's get used to using the word discriminant. What is the discriminant? -8. People with a little bit of number sense or have the luxury of stepping back and taking a look at what they wrote, they should recognize something odd or something not good about that statement right here. What am I referring to? Something's not proper or something's very problematic about that statement right there. Yep. That's it. Take a look at the discriminant. This time it's a negative. Like it was said, oops. Not square root negative number. Okay, so you say therefore, when the discriminant is negative, there is no root for I'll just say no root. So when y equals 0 in this case, x does not exist. So the quadratic formula works. Mathematically, there is a mechanism already built in that will tell you if there's going to be 2, 1, or 0. And if there's 0, they tell you by saying it's impossible to solve. You could even try that in the calculator. And as long as you are putting this in the calculator in the correct order, it will say, hey, there's a problem, error, square root of a negative, that's an imagination. And it only exists in non-real worlds, which is a part of math. But we don't care about that because it doesn't apply to real life. So the take home for today, anytime you have to use a quadratic formula, even tomorrow in your quiz, okay, I'm not going to throw that at you just yet, right? You just learned it. But even tomorrow in your quiz, you might want to start with the discriminant just to see if you have to do everything. Like, do you really have to write out negative b plus minus square root? Do you have to write out 2 times 1? No. Why not just go straight to this part right here? Calculate b squared minus 4ac. Calculate the portion underneath the square root and see if it's a negative or not. If it's a negative, you don't have to do any work. You're done. You say 0 answers. But if it's a positive or a 0, you continue on and finish the quadratic formula. Okay? Let's see if there's a way to test whether I have to go on or not. I do have a couple of questions for you for your homework. Let's do one together, okay? I'm going to clear this. Everyone's okay? Yeah? Let's clear this. Let's do one for me to show you exactly what I mean by save yourself trouble by doing the discriminant first. Now, the answer key, number 2b, tells me that there are no answers. But let's pretend I didn't see that. Here's what I would do. All right, number 2b. My a value is a 2. My b value is a -1. And my c value is a 5. Okay? The question says, determine the number of real solutions of each quadratic equation. And it even tells me, don't solve it, just tell me how many roots there are. Some people, when they're like, oh, how many roots? I'm just going to solve it and count how many roots there. No, you can actually do a shortcut because that's what the discriminant is for. B squared minus 4ac. Remember, that portion is underneath the square root. So tell me what's underneath that square root. B squared minus 4 times a times c. That is equal to -1 times -1 is a positive 1. -4 times a 2 times a 5 is -40. Huh. The square root portion is a negative value. What does that tell you? Is it possible? No. Can you find x values? No. There are no roots. You can't solve it. So no answer is possible. That's it. This will tell you whether the parabola is, going through the x-axis or touching it or completely off of it. Gives you a better understanding. I'm going to ask you for your homework to at least try some of the K-style questions. So I think number 2, 4, and 5 in the least would be a good place to go. If there are too many questions for you, then try every other. So maybe A, C, E, and then mix it up. Maybe B, D, F, and then try number 5. Do whatever you need to get yourself more comfortable, more confident, because you know that you're aiming for another quiz tomorrow. And well, the chapter 4, there is going to be a unit test as well, right? It's going to be shorter, but still, this was the unit test. Any last questions? Yes.
So is tomorrow practice?
Yes, it is. So Thursday is the real one, and then Friday I have in class something for you because it's a shortened period. And then when we come back, we'll maybe do a review and then have our final chapter 4. That's it. We're done with polynomials. Yay for you.